Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. I'm Madam Normaliza binti Asman. Today, I want to let you to review the concept of chapter 4, forces. Okay, let's review our learning outcomes. For this topic, we have two subtopics. First, we need to learn about the basic of forces and sketch free body diagram. And secondly, we need to know about Newton's law, where you can state the Newton's law and also apply the Newton's law. Okay, let's discuss about subtopic 4.1, basic of forces. Actually, you need to know 5 basic of forces acting on body. First is applied force. Okay, you can look at this figure. Okay, we have two types of force actually, pulling force or pushing force. Okay, next, normal force. Okay, actually the normal force acting on the surface which is perpendicular to the surface. Third, frictional force. So frictional force actually oppose the motion on the rough surface. Fourth is about weight. Okay, weight actually is the mass influenced by gravity. And also the last forces is tensional force. Okay, this tensional force acting on rope or string. Okay, remember that the SI unit of force is Newton. Please note that the applied force does not exist when object is released from rest. We can look this example. Okay, when the object is placed on inclined plane, initially at rest, there is no existence of applied force. Okay, normal force is not always equals to mg. Actually, it depends on the vertical forces acting on body. So to prove this statement, we look at example 1. We can look at this figure. When the summation of n equals to 0, so from this figure, we look at the vertical component for this object. We have normal force, Fy, and weight y. When we resolve this formula, we get that the normal force equals to weight cos theta minus F cos theta. Okay, let's look to the example 2. So you can see the figure here. So when the net force equals to 0, so we look at the vertical component for the forces here. So we have two forces, normal force and weight y. Okay. When we resolve this formula, we get that the normal force equals to mg cos theta. This is proof that the normal force is not always equals to mg. Frictional force exists on the rough surface. Its direction is always opposed to the motion of the body. So this is the formula to determine the frictional force. Frictional force is equals to N
where nu is referred to coefficient of friction and n is referred to the normal force. So we have two types of frictional force. First is static friction and secondly is kinetic friction. So when we compare these two types of friction, the magnitude of static friction is greater than kinetic friction. According to this formula, so we can say that the magnitude of frictional force is directly proportional to the coefficient of friction, so that we can say that the coefficient of static friction also greater than the coefficient of kinetic friction. Did you know the frictional force and normal force, also known as reaction force, both react on the surface?
Okay, next we go to free body diagram, or we call it as FBD. Okay, look at example 1 for inclined plane. Okay, so before we start sketch a free body diagram, so first you need to identify the all forces acting on body by sketch all forces acting on body. Okay, you can label the force here. And remember that to sketch free body diagram, only the basic force means that x and y component here is not included in our free body diagram. So this is the step how to sketch a free body diagram. So this dot actually represent a body. Okay, we look at the example 2, pulley system. So same with the previous, you need to identify first the forces acting on object. So for this pulley system, we have two objects. So means that you need to sketch different free body diagram for different object. So this is the step how you sketch a free body diagram. Okay, next we continue with subtopic 4.2a, state Newton's law. So we have three Newton's law, first law, second law, and third law. Okay, first we discuss about Newton's first law. Newton's first law states that the net force is equals to 0, where the acceleration is equals to 0. No acceleration. So the object must be in equilibrium state. So we have two types of equilibrium. First is static equilibrium, where the object at rest or no motion, where the velocity is 0. And secondly is dynamic equilibrium, where the object moving with the constant velocity. So when we look at this equilibrium state, there is no acceleration acting on a body. So the net force is become 0. So for Newton's first law, as we can make a statement that object rest remain rest, or object move will remain moving with a constant velocity. Okay, now I want to share with you how to identify the direction of force according to Newton's first law. So recall back the condition for Newton's first law. The net force is equals to 0, where the acceleration is also 0. So to indicate the direction of force, first we make an axis as a reference.
Okay, so if the force is to the right from origin, the force become positive. If the force left from origin, the force become negative. If the force above the origin, the force become positive. And if the force below origin, the force will become negative. Next, we discuss about Newton's second law. So Newton's second law states that the net force is directly proportional to the rate of change of momentum. So this is the condition for Newton's second law, where the net force is equals to ma, where the acceleration is non-zero. So the object is moving actually with constant acceleration. So we have two types of motion here. First is horizontal motion and secondly is vertical motion. So we can look the condition for each motion. First we look at for vertical motion, the condition is become the summation of Fy is equals to ma, where the summation of Fx is equals to 0. And for horizontal motion, the summation of Fx equals to ma, while the summation of Fy is equals to 0.
Now I want to share with you how to indicate the direction of force for Newton's second law. So we recall back the condition of Newton's second law. The net force is equals to ma, where the magnitude of force is directly proportional to the magnitude of acceleration. So the direction of net force actually is depend on the direction of motion. So let me identify the direction of forces. So for Newton's second law, the motion become reference to indicate the direction of each forces acting on body. If the force is same direction with the motion, the force will become positive. If the force is opposite direction with the motion, so the force is become negative. Okay, next we discuss about Newton's third law. So Newton's third law states that for action-reaction force, the force is same in magnitude but opposite in direction. So this formula proves that the action-reaction force have same in magnitude and opposite in direction. So the direction is indicated by negative sign here. Okay, so this is an example of Newton's third law. So we can look at this figure, figure 1, figure 2, and figure 3. So we have actually action-reaction force here, and these two forces have same in magnitude but opposite in direction. We continue with subtopic 4.2b, apply Newton's law. So I want to share with you the step to apply Newton's law. So you need to follow these 3 steps. First is sketch all forces acting on body, or we can sketch a free body diagram. Secondly is you need to state the condition of the net force. Either the condition is Newton's first law or Newton's second law. And finally, you can resolve
the component of force. Next, let's recheck our understanding. Let's look at example 1. There are 3 questions for this question. So before we start answering this question, so you need to underline the information given in the question. So we go to first question. Sketch and label all the forces acting on M1 and M2. Okay, let me find the solution. This is our first step. So you need to identify first the all forces acting on the object, and then you label. Okay, this is from the question. And for your solution, we draw the structure of object. Okay, different object have different figure diagram, and you label the all forces acting on each body. If the question asks you to sketch a free body diagram, so the object will represent by dot. Next, we go to question number 2. Calculate the acceleration of the system. Okay, let me find the solution. Okay, because of the question asked about acceleration, first we need to state the condition. Because this is actually Newton's second law, so we state first the condition of Newton's second law, the summation of F equals to ma. So by referring to this two free body diagram, actually we have 2 types of motion. For first object is actually horizontal motion, and second object is refer to vertical motion. So each free body diagram you must state its condition. So the summation of fx is equals to a. This is by referring to the first free body diagram, and the summation of fy equals to ma while fx equals to 0. This is referred to the diagram 2. Okay, before we resolve the force, okay, so we need to review again how to indicate the direction of force. Okay, so this is time for resolve. Okay, before you resolve, okay, make sure you write down the information given in question. M1 is equals to 2 kg, M2 is equals to 3 kg. So according to this figure, so we write down the condition, summation of fx equals to ma. Okay, and then you follow the step, substitute the value of m, and for this equation, we have a 2 unknown, and we make this formula as equation number 1. So we refer free body diagram for object 2. So same with the previous, you state the condition first by write down the condition, the summation of fy equals to ma, and then you substitute the value. So make sure before you resolve, you identify first the direction of force here. So for this figure, so tensional force actually opposite with the direction of motion. That's why the value of T here is become negative. While weight 2 actually is same direction with the motion. Okay, we said that the weight 2 is become positive. And then we substitute the value, and also we find that we have two unknown. So we make this equation as equation number 2. Okay. By referring to equation 1 and equation 2, you need to substitute the equation 1 into the equation 2. Okay, you will rearrange the formula and finally you get the A is equals to 5.89 meter per second square. So make sure your final answer in 2 decimal place and correct unit. Okay, now we look at the question number 3, calculate the tension in the straight. Let's find the solution. Okay, from equation number 1, T is equals to 2A. Actually, we already know the value of A for previous question. So we substitute the value of A here, and finally you get the value of T. So make sure your final answer in 2 decimal place and the unit is correct. We look at the example number 2. This is example 2. Figure 2 shows a 7 kilogram box sliding down an inclined plane with a constant velocity of 4.2 meter per second until it reached the bottom of the inclined plane. So calculate the coefficient of the kinetic friction between the box and inclined plane. So let's find the solution. Okay, first step is we need to sketch a free body diagram. Okay, so before you start sketch a free body diagram, so you need to label all forces acting on objects. So we have frictional force, normal force, and also weight, and we transform it into free body diagram. Okay, next we state the condition. So actually this is Newton's first law because in the statement mentioned about constant velocity. So we write down the condition first. The net force is equals to 0, where the acceleration is 0 because v is constant. Okay, by referring to the formula of frictional force, kinetic friction is equals to coefficient of kinetic friction times normal force. So how about the value of mu k? Now we resolve the question. Okay, make sure you write down the information given and state the condition for x and y component. Okay, make sure you check first the indication of force here. So because this is first Newton's law, we make axis as our reference to indicate the direction of force. So the frictional force here is positive because to the right from the origin. Weight x is negative because left from origin. So from these two equations, we get a value of Fk and formula for n. So by referring to the formula F equals to mu n, we arrange formula. So you know that the mu k is equals to Fn, and we can cancel out this value of mg. and sine divided by cos, we get tangent theta. So that and then you substitute the value of theta here. Finally, you get the value of mu k. Then say 0.70. So for the coefficient of friction, there is no unit. Okay, let's test your understanding. Try yourself to answer this question. Okay, this is not end here. So you need to do a lot of practice. Okay, so try solve various problem for topic courses to check your understanding. So to become success, you need your effort. Okay, inshallah, I ending my presentation with Assalamualaikum warahmatullahi wabarakatuh.